Great. So here we are. Hi, everyone. Welcome all to this workshop, a Landing.Jobs initiative connected to the willingness to share more knowledge and empower our community and tech professionals. So don't be shy. Please say hi in the chat box here on your right. My name is Christina, and I'm an event specialist at Landing.Jobs talent team. Just a quick note for the ones that don't know regarding our company. So just give me 1 second. Yes, here it is. Regarding Landing.Jobs. So we are a candidate-driven tech careers marketplace. And we are dedicated to matching great tech talent with great opportunities. So we work with amazing companies, and that's mainly our mission, is to help you in your tech career from the beginning until moving, changing, and relocating as well, getting your payment, and in the end being happy, okay, doing what you like. So some technical and introductory details now. We want you to get as much as possible from this workshop, so feel free to ask your questions wherever they are. I see that some of you have never used Python, so don't be shy again, and there's no wrong questions. That's what we are here for, so we'll answer all of them by the end of the session. Then we also want to know a bit more about yourselves, so we can get to know each other. So please use the polls that we have made. They are also in the bottom of the screen. And that's it, I think. So I'll now present our guest, João. So João has a background in mechanical engineering, and as many others, he decided to join Le Wagon as a student first, where he got specialized their already existing coding skills, and is now the data science teacher for Le Wagon Lisbon. And I'm sure he can present himself much better to himself and the topic that we are discussing here today. Please welcome João, and the stage is now yours. I'll be back by the end of your talk.
Thank you. Hi, everyone. I'm João. As you said, I am a teacher at Le Wagon for data science. I'm going to start sharing my screen to show you some slides. Can everyone see all right? Looks fine. Okay. So as I said, I'm a teacher at Le Wagon Data Science. One of the many things we learn in that 9-week intensive bootcamp is web scraping. It's an important base for data science, but it's a good workshop to give in general, because it can give you uses outside of data science as well. It's not just for data science. So what is the web scraping? So as everyone knows, the internet is full of data. The world is almost based on data nowadays, or how you use it, whether it be for marketing, for making products, for AI. Data is really important. And one of the many ways that you can get data is through web scraping. So web scraping is used to get data from public internet sites, and you can get structured data using software to get a lot of big amounts of data at once without having to go and manually copy pasting. So the goal will be to get a web page like this one on the left and be able to end up with a data frame like this one full of information, right? You could technically, it's all stuff you could do by copy pasting manually, but that would take someone a long time, if not hours, to just do one web page. And the advantage is that we can use our computer and Python and software to automate all the work, so that you can get a lot, not only for potentially just one page, but for many. So where is web scraping used? As I said, we use it a lot in data science in our bootcamp to make AI products, whether it's to get, for example, data on real estate, and you can make a product that aggregates real estate from lots of different web pages, web sources, and you can make an AI model of that. And another very famous example that we don't cover in our course, but it's definitely maybe the most famous example of web scraping is Google or any search engine like that. It's using basically a form of web scraping to be able to, in one place, get information from the entire web. So it's a really important part of our world, of our data-centered world. And so we'll give you a bit of an introduction on some things that you can do today. Also, just to give you some context, we have this website that we're going to be working on today. That's kind of a dummy website that we're going to use. And it has some books, and we're going to maybe try to get all the titles and prices of books as an example of something that you can do already today by the end of the workshop. Okay, so all you need to do web scraping is a URL of the page that you want to scrape. You'll have to manually kind of look through and decide what data you want from it, and then we're going to write a code to get that automatically. So a little background on how the internet works. So generally, if we ignore what we're going to do today in the workshop, just a normal person will be accessing through, for example, Google Chrome on their laptop. They're going to ping a server whenever they click enter a URL or click on a specific page inside it. It's going to ping a server. The server is then going to return you some HTML code. And that's what you're going to be seeing in your, like, Google Chrome will make the HTML look more pretty, but basically it's that HTML code has all the information that you need to visualize the web page in your computer. So what we are going to do is use Python and make a script that, instead of us clicking the buttons and entering stuff in our browser, it's just going to be automatically pinging a server, getting that HTML code anyways, and then we're going to have to interpret the code that's inside there to get the information that we want. So I'll leave a bit of space for questions right now. So if anyone wants to put in some questions, I can answer now, just in terms of introduction. We have someone here already, which is, how adaptable can we be web scrapers for pages that have their design changed with some frequency? This has been challenging for our company, so we ended up copy pasting data again. So that's a good question. It really depends. Sometimes, one of the great limitations of web scraping is that you really rely on the code that's on the website, right? And that is not depending on best practices. It's depending on whoever was the programmer that made the website. That's what's going to dictate the code that's there, right? And there is a chance that that code can change slightly on a normal website, but even though that's a bit unlikely, that just would mean that you have to change your own code every time that changes. But a lot of the times what happens is some websites are aware of web scraping, and even though it's illegal to do web scraping, they don't want other companies, other products to be using their data. So they themselves purposely are like constantly changing the code. They can even automate that. And that really makes it much harder. You need to do be really an expert in web scraping to be able to like adapt to the ever-changing code. That should, in theory, only happen in like the really like high-tech websites. I think LinkedIn, websites like that they have like teams of people that are there to make it your life hard to web scrape their website. But yeah, so that's not something we're going to be covering so much in this workshop. We're going to start more with the basics, but eventually even that, basically there's a cat and mouse chase between programmers and web scrapers to make it as hard for each other. But it's an ongoing battle, and for sure there are people that can web scrape basically any website at the moment. It just gets really advanced on some websites. But for a majority of websites, I think that it shouldn't be a problem. We have another question, which is what to use as your platform to code. I use Jupyter Lab. So yeah, exactly. I'm going to go over that in a bit. I am going to be using Jupyter Lab, or you could use Jupyter Notebook as well for this workshop. And it is a really good tool to use whenever you're not necessarily to make a final product, but to when you're starting something, you're exploring data, exploring your code for web scraping. It's a really good tool for that. Another question is, when you say HTML, could those be dynamic generated HTML? An example is JavaScript that loads and might load a bit slower than other pages content, so I have to wait for it dynamically. So again, that's another problem with web scraping, which we won't cover here in this workshop. It's a little bit more advanced, but yes, you're right. Some code, some websites have dynamic HTML because they're using JavaScript. And I will mention it for you later on. There is a package that you could look into that will help you scrape pages that are based on JavaScript. So it's something you could look after this workshop. Yeah, okay, that's enough questions for now. So let's go on. As I said, we are going to be using Jupyter Notebook for this workshop using Python because it's just a really good way to visually do some explorations so we don't lose code that you've done before. And it's just a great way to write code that doesn't have to be very final yet. And for web scraping, a lot of the times you don't even need to have finalized code because you might just want to run it once, right, to get all the data you need, and then you don't need to save that code anymore. It can just stay in your Jupyter Notebook. We're also going to need a modern browser, so we recommend using Chrome or Firefox. I do believe Safari has a lot of the same tools, but personally, I prefer Chrome or Firefox, and it's going to help us do the more human side of looking through the code and checking where in the code some elements of the page are. And that will help us then write the machine side of it to be able to find the proper places in the web page. Also, so Python, one of the main advantages of Python over other programming languages is that you have like millions of packages, libraries that you can just install onto your computer, and it's basically code that someone else wrote and you can reuse and tweak slightly for your purposes. So one important package for web scraping is Beautiful Soup, which you would need to install in your computer. I already have it on mine. And we're going to import it into our code and use it ourselves. And as I mentioned before, another library you could use is Selenium. So I can try Python Selenium, exactly. So for anyone curious, for after this workshop, you can use this Selenium with Python, that's only if you're trying to scrape a more complex web page that is very dynamic and uses a lot of JavaScript. So that's something that you could look into after. Okay. So as I said, we're going to use this Brooks to scrape dummy website to scrape. The reason why we're doing that is so that we don't have any headaches just in terms of the workshop. It has no authentication. Basically, since web scraping is basically completely legal, but it has some gray areas only if you're starting to get to places where you have authentication, and especially if it's a paid authentication website, then you're getting more into a gray area of whether it's legal or not. But anything that's public, no authentication, nothing, is perfect. It's completely that no one can do anything about you scraping it. Also, since we wanted a page without JavaScript so that we can use Beautiful Soup, and it's actually just generally a good representation of pages that you might want to scrape. Some other examples would be, for example, the IMDb pages have, like, for example, top 10 or top 50 or top 100 movies of all time, and it's a web page structured with lots of repeating content. So in this case, it's many books that have all of the same title, price, format, review. And there's many websites like that. IMDb is one, probably Wikipedia pages. You can get tables from there, and just generally a good reason to do web scraping is when you have like repeating patterns inside the web page so that you can scrape all of it. Okay, so in order to, yeah.
Sorry to interrupt. So could you just please share the Dumby website and also the tools you're using here in the chat box so everyone can follow? Thank you.
The Dummy website, yes, okay. Is my screen still sharing or no?
No.
Okay, perfect. Share that again. That's the website. And sorry, you wanted me to share two things? It was the website and something else?
I don't know if it's needed, but the tools, the tool you're using, that they should download.
Yes, Selenium. I'll share all of this. So the one I'm about to post is the Selenium package, which we are not going to use in this workshop, but it's to do with a question about JavaScript. And beautiful.
And to all attendees, I must say as well that by the end of the talk, we'll share also the slides and some exercises so you can continue practice later on if you want to. Okay. So.
Okay. So in terms of, to be able to scrape a website, you really have to have some understanding of the HTML code behind the page so that you can like be able to target the specific information that you want. For example, if I go to this page that we're going to be scraping, I can right click and click view page source. And here is a very large HTML piece of code, which, I mean, it's very hard to interpret even if you do know what's going on in here, but in general, you need to have an idea of what all of these tags are so that you can search for the proper information. So as I said, HTML basically works with these tags that are with these arrow symbols. So you have an open tag and a closed tag, which has this slash, and they are defined by different types of elements. So the first thing in each tag will be the type of element that the content has inside. So you can have links, you can have headers. We'll look a bit into that after. Another thing you can have inside the tag is an attribute, and there's no limit on the amount of attributes you can have. And this is more for the side of the programmer that's making the website, for them to be able to add more specific context to the content. So an example of a tag is here on the last one. It's an A tag, which is a link. All the links need to have an attribute, which is the href, which is the URL that the link is referencing to. And inside the tag, we have the text that will display on the browser, which in this case would be Wagon. Right, so you'd get this as a clickable text on the website that goes to this URL. Another important thing to know about HTML is kind of the general structure of the whole code. All of the code has to go inside this HTML tag. And then you generally have two different sections of the code, which is the head and the body. The head is metadata, so it's stuff that won't be displayed on the browser, but it's used for example, when Google is crawling the internet and getting information to display on Google, a lot of the information is here. And then you have the body section, which is actually the information that's showed in the browser for humans. So it can look a bit like this. For example, the head has these meta tags, again, for the computer's side of things, so that they can know the description of the website and the content and just the type and just general things that aren't specifically important for the user to see, but for the backend to understand. Okay, so examples of HTML headers. The first main one is the H elements. It starts with H1, H2, H3, H4 is for titles. So basically, this is the biggest text that would appear on a page. This would be a subtitle, the second biggest, and etc. You have the P element tag, which is for a paragraph. It's just for general text that you can have inside your page. And if you put several of them in a row, it will divide them into different paragraphs. A really important one for web scraping and generally in web design is this div tag. It's generally just more for an organizational aspect. So you want to split your web page into several sections. Each section, or you can think of it as a box that has content inside, is usually a div element. And then inside it, you can have lots of paragraphs and headers, and then another section would be a different div tag. So it's kind of an organizational tool to separate different content in your page. And the reason why it's really important for web scraping is usually you want to find repeating patterns in your web page. And one way that they can repeat is just different divs will have the content inside it. And you can also have tags specifically just to change the text a little bit. So you can have a strong tag and there's tags to make it italic. Usually it's not as important for us. You have unordered lists. So UL for unordered lists, basically it's just to have bullet points. That's, again, could be very important for you in web scraping. If you just want to scrape a web page full of bullet points, you can just search for this LI tag inside the unordered list, which means it's one bullet point, and you can get all the different bullet points and save them. The same thing is very similar for ordered lists. So here it's a list that starts 1, 2, 3, 4, and so on, but the structure is very similar. And another very important one, not so much for data scraping, is an image tag, which has the source, usually a file or a link to a website just has an image. And it has also this attribute, which is alt, which is just text that displays if the image fails to load on your browser or something, or if you're visually impaired and you're just using readers for websites. This is the text that will read out when the image is going on. So it's actually kind of important. And for us, in terms of identifying images, usually we won't be able to identify an image through the file name or the URL name, but maybe from the text you can. Or if you just want to scrape the text from basically the description of the image. Okay. Any questions so far? I'll stop sharing. I think there is one question. Okay, it's the tools to get them. Okay, that's already answered. I will keep going. So, as you saw, there's lots of different tags that you can use that is used in HTML. And again, I talked a little bit about the structure of the different tags, but again, you really need to understand the flow of HTML to be able to grab specific information. So in HTML, you tend to have like a bigger box of content that inside has more content and more, and it gets smaller and smaller. So there's kind of a general structure to HTML that you need to understand in order to get just a small part of the data instead of just everything that's in the website. So one way you can think of it is kind of this nested element. We use this structure because in best practice, if you're programming correctly, you should be indenting the code, and that kind of shows you what's inside what. So this whole code here on the right, you can see from top to bottom, it's one article tag. And you can see everything inside it is a bit indented to the right. And basically you have one div tag, a paragraph, a header, and another div tag. And again, inside of this div tag, you have more content, and it's indented to the right, and more content indented to the right. So basically, if properly done, a HTML code should look like this, in which you can, by the indentations, kind of identify like a big chunk of code that has smaller chunks inside it. So very useful in terms of visualizing yourself as a human, what's inside of the HTML code. But the more important metaphor that you can use for HTML code is a tree structure. You usually more think of it as an upside down tree, or I tend to think of it more as a root system of a tree. But basically, we think of it like that because if you're not actually visualizing the HTML code, but just thinking of what's inside it, you start with a main chunk of content, and usually always the HTML code, and inside there, as I said, you have the head and body, and you can go further down and down into smaller sections of your web page that you might try to get the content from. Okay, and importantly, we usually think of it as genealogical trees instead of just regular trees, more in terms of terminology, especially if you're talking to someone else or trying to explain something to someone else. It's much easier to use this terminology to identify different sections. So we talk about ancestors and descendants in HTML code, and basically it's just thinking of it as exactly like a genealogical tree. You have in this case, there's 4 generations: the great grandfathers, the grandparents, the parents, and children. The images here are not very correct. I don't think these people would be having children at this age, but you think of it like that. But on any part, you can take, for example, this p tag. You can say the body is the parent tag to this one. HTML is the grandparent tag to this one. These are sibling tags, and children tags or descendant tags below them, right? So just for you to think about the relationship between the different tags, or especially if you want to explain it to someone else, it's useful to use this terminology. So I will take a bit of a deep dive into our web page now, so we can try and identify some of these tags. So if you go on Google Chrome, and it should be similar on other browsers, if you right-click the page, and you should have something similar to an inspect. If you click that, and it brings this menu here, usually on the right of your browser, and that's going to be used for us to look at the HTML codes. So just by hovering with my mouse, and you can open these. These are all like descendant tags from this top one, and you can hover and see where in the web page it is. But more useful than that is you have, at least on Google Chrome, you have this button right here, which is for selecting an element. And then if you hover something that you might want to scrape, let's say the title of our book, it will show me in the source code where that information is here. So if you look at this HTML code, it has the A Light in the Attic, which is the correct title that I just selected, okay? And from there, I can actually try to see where in the code it is, okay? So it has this h3 tag, which is the parent tag to it, which is inside this article tag, which is the grandfather tag, inside a list. So you can think of the books as being a list of books. It's inside a div, and so on. So here, by hovering and using this inspect thing on Google Chrome, you can more easily find out the structure of the code, right? If I just looked at the page source, I'd have to maybe Control F and find the right title, but you might not know what the title of the first book is, and it's just hard to just look at HTML and identify everything. You can use these tools to more easily find the correct places in the HTML that has the content that you want to find. So here I can click an image, and I see that this is the link of the image, and it has this sharp objects description on the image, and so on. Any questions so far? Feel free to leave as many questions as you want. So very soon I will start actually writing some code for you, and maybe you'll have more questions in regards to that. I saw, I think here in the poll, not many of you have used Python before, so feel free to ask any question that you want. But soon enough, I'm just going to jump into the notebook and write some code for you. Okay, just to wrap up a few things. So to recap, you have tags in HTML, which are different elements, so links, headers, stuff like that. They have different attributes inside them that can be useful for us to identify specific content, and inside the tags, you have the content. And this usually is what we want to scrape. What are the attributes that are most common? If you take a look at just this general code of HTML, you can identify there's this class attribute, this ID attribute. href is very common if you have a lot of links, but these two are very important attributes. And why are they so common? Is basically there's a CSS that is used by programmers to give uh, it's more of a visual aspect to the web page and have more control over that. We're not going to cover CSS today. It's not really important for you for web scraping, but basically for the programmers that are making the website, for it to look pretty, they will have to be using a lot of these class and ID attributes in their functions so that they can, for example, identify, oh, this section should have this color or this font or anything like that. So it's very common for programmers to use these attributes. So a bit of a reality check. Is a lot of the HTML content out there very readable? No. If you take a look at the HTML code for this LinkedIn page, it's this jumbled mess because it doesn't really require a programmer to make the HTML look very pretty, because the end user is not really going to be looking at the HTML code. They're going to be looking at the browser. And the programmers don't have any reason to make it look very nice and organized other than if they're collaborating with other people. So you're kind of relying when you're doing web scraping on the quality of the code that someone else wrote, which can be a bit of a pain sometimes, but that's the life of web scraping. Each page, each new website that you're trying to web scrape is going to be different because it's a different person that wrote the code. But something that helps is we're going to use the beautiful soup package because it's going to take this jumbled mess of elements, a soup of elements, and we're going to parse the HTML and we're going to use that to grab specific elements that are important to us. So even though you need to kind of understand HTML code to do it, once you write the code and you have the script file on, writing the code itself isn't that difficult. It's more the initial understanding of what the code is doing that can be a bit of a pain. So, as I said, we're going to use the beautiful soup package. I sent you the link already. You can take a look at the documentation there if you have extra questions that we don't cover in this workshop. And generally, it's just a good habit to go and look through the documentation anytime you have a question, and it could be useful for you if you're trying your own web scraping after today. So I'm going to start writing some code. The goal, as I said, for today, we're going to do a few things first to kind of warm up, but the goal is to get from this page a data frame with all the titles of the books and all the prices. Okay.
João, before you go, there's a question here. I believe, can I read it to you? Yeah. So it's from Chioma, and she's saying, sorry to drag us back a bit, but how did you get the HTML section on the web page you visit?
Okay.
So Ricardo already gave here some help, so not sure if...
Okay, so yeah, you can access it there, but I'll show you how to get it just because it's very useful no problem in asking these kinds of questions. So it's very important to. This is actually like you really need to be able to do this for any website for you to do web scraping. And at least on Google Chrome, it might vary a bit on Firefox or Safari, but it should be really similar. On Chrome is if you right click anywhere on your page, ideally like somewhere blank like this, you have this option which is view page source, and that gives you the full HTML. But personally, I don't use that a lot. I do use the inspect that I was showing you earlier, because here on the right, even though you have to kind of open the little sections, it has all the HTML code as well, and it's just nicer for you to visualize because you can see and click and see what each different thing here is. So that's definitely the recommendation I always give. And if you don't use Chrome or Firefox yet, then I definitely recommend that you use that if you're going to be doing web scraping. Especially as you get into more advanced web scraping, I would recommend Google Chrome, because the Selenium package that I mentioned earlier, if you're doing JavaScript and stuff like that, has to be done on with Google Chrome. So that would be my recommendation. But for today, Google Chrome or Firefox should work. Okay.
Before you go,
Yes.
she's also asking, how did you get it to be side by side?
F12. Yeah.
Well,
On
Rob is
mine,
paying
it
attention
depends.
and giving some answers as
Yeah.
well.
It probably depends on also on the size of your browser. I don't know if you have it full screen. Maybe you have the video currently on your computer side by side with your browser, and that could make it look a bit weird. So generally, you would want to have it maximized, and so it should automatically go. But it depends a bit on your settings, as some people are pointing out. Okay, so let's start the writing some code then. I'm gonna put. Okay, so this is the page we're scraping, and I'm going to write code here in Jupyter Lab. So here is a notebook from Jupyter Lab, as we talked about before, and here you basically can write any Python code you want. You have these cells with code. You can have text cells like these ones, which just have some text, or some code cells down here, and you can write any Python code. You can like do simple maths. 1 + 1 is 2. I'm using Shift Enter to run the cell. You can write a string, which is text, hello world. It goes in quotes, and you have here the text. And as I saw, many of you haven't used Python a lot, so even though I'm not going to go through all the basics of Python. Generally, for today, the important concept to grab is, especially if you used other programming languages, it should be straightforward, but is the concept of variables. So if you want to store the information, any information that you want, you can store it with just general text name. So my variable, for example, I can make that equal to hello world. And it doesn't really do anything yet, but if I now print to see what my variable is, I can print my variable, and it should say hello world. Okay, so it's basically a way of storing information. And you'll see down here that there's some code. Later on, we're going to send you the slides that I've been using today, and all of this code that I have on the notebook right now is on the slides, so you don't have to write it down right now. But you'll see on this code a lot, we're having these equal signs, so basically we're saving some text or code or anything to variables in this way. And I'll try my best to explain what I'm doing as I go, but if anyone has any questions of specifically how I did anything, just let me know, and maybe I can be interrupted to make sure that I don't wait too long for that. So the first setup steps that we need for doing any web scraping with Beautiful Soup, luckily, are always the same. So you can basically copy paste what I have here, and it should work for any URL. All you have to change is this URL here, and you'd be able to do the setup for starting to scrape something in the exact same way every time, especially as long as it's HTML code. but I'll go over the steps very quickly. So we need two packages for whenever you're using Beautiful Soup for scraping. There's this requests package that you import this way, and that's by default already exists in Python, so you don't need to download it. As long as you have Python, you will have this requests package. So you import that, and we're importing Beautiful Soup in this way. And for that, it is an external package. You need to download it before using it. If anyone is, you can even just Google download or install Beautiful Soup Python. Should be quite straightforward to install it. Exactly. So this link I can share on chat. You can copy paste this into your terminal, and as long as you already have Python, it should install Beautiful Soup for you. So let me just put that in chat. Okay, so with our Python packages imported, we're going to have to set up and basically do that process that I explained before of pinging the server, getting the HTML, and we're going to put it inside the Beautiful Soup package so that we can use it to kind of parse through the mess that usually is HTML. So we're saving the URL to this URL variable. This URL can be any HTML page. Then we're going to use this request packages, and that's basically the part that's pinging the server. And we're going to do .get URL to get basically get the response from the server. That's why we're saving it under the response variable. And I'm actually going to zoom in case we can't see properly. From this response, we can do .content to get the HTML code from the response, the HTML file basically. And we're going to use this Beautiful Soup package to interpret the HTML. And so all of this is to end up with this variable called scraped, which we're going to use throughout the rest of today. And basically, it's an object created by the Beautiful Soup package that has all the content of the page inside it, and we're going to search for specific parts of the page through this saved variable. Okay. So the first challenge we can do, just kind of to warm up, is try to scrape a single element. So first, I'm going to try and get the title of the page. So the title is actually what appears here on my tab at the top. It has some text inside it, and I'm going to try to scrape the full title of this web page. So it should just be one tag that I'm looking for, basically. So useful text that useful code that we can use to find things inside our script full of HTML content. So you can do .find as a function from Beautiful Soup to find a specific tag. It will find the first instance of that tag. So I can, for example, I see straight away here, since it's the title, it shows at the very start of HTML, I have this title tag here. So I can do .find title, and it's giving me just the first time it finds the title tag. But in this case, for every website, you only have it once. So you get the title tag from just doing this. After that, you might not want the entire tag. Usually you don't. You want to get a specific part of it. Usually you want the content inside of it. So you can do .text, and you get a string. So with the quotes, that means it's a string. It's text, and it has the text inside of the HTML title tag. Okay. If you might be wondering, why does it look so weird? It has these \n on either side. So in programming, \n means new line. So I can show you, for example, print hello \world. Now it's printing the hello and world in different lines, right? It's making a new line after the hello. So that's kind of what was happening here. It has the new line at the beginning and end. But, and this is kind of a good thing about Python, is you can chain a lot of code in the same line. You can do .strip, which is just a general Python function that you have that can be done on any text. If you do .strip, it removes any white space that is before, at the beginning or end of the string. And that includes new lines, tabs, anything that's like on the browser would show up as white space, empty space. It strips that away on either side. But notice it's not taking out the spaces in between. It's just at either side. So that can be very useful for you in lots of different situations, because sometimes, even though since the code is made to be looked at in the browser, it has weird white space, empty spaces, new lines in the middle of the text sometimes, just to make it more readable for the end product. So it's a good function to keep in mind. For those that are more experienced with coding, an alternative to this find function on Visual Soup is to just write the what would go inside here of the code. So if I do .title here, I get the same thing. So basically, this is the same as doing scrape.find title. That applies to any tag. I can do an A tag. These two things are the same. It's finding me the first link in the HTML code. I will, for the rest of the workshop, be using this find, but I tend to, when I'm doing this on my own, I use this syntax, which is a bit faster to write. Okay, so we got the title. Now let's try and get this warning text. Now, if I print the scraped again, which has all my code, it's starting to get way further down into my HTML code. And it's going to be hard for me to identify just by looking at the code. And that's when the inspect tool comes very useful. So I can hover, after clicking here on this inspect tool, I can hover the content that I want to scrape, click it. And I see here on the right, the HTML code. I can try and zoom in as well. I have the HTML code that has the content inside. But one thing you can notice, it's a div tag, which there are div tags all over. So if I did scraped.find the div, which is the way you would do it, this will only find the first div tag, which is not the one we wanted, right? It's saying we love being scraped. It's basically it's finding this text here. So what do you do when there's lots of the same tag and you don't want to look, you want to get a specific one, but it's not the first one? So here's where the attributes really come in handy. So this tag is the div tag, and inside we have two attributes, class and role. And this one looks a bit more simple. So you have this role attribute. We don't really need to understand why it's there. The programmer put it there for some reason, but it looks, since it says alert, like something that's very unique to this warning message. So it's probably not going to be an attribute that you could find somewhere else in the page. So it's a good candidate of something that you can specify to find this particular content. So here we do have to use this find syntax. You can't use the one I was showing earlier. And as a second parameter, so here is all the things that we are inside the find. We can put a second parameter, and that will be just the name of the attribute. So I'm going to put the parameter to be, basically I can copy paste this. I can't select it, but it's copying this text here. I put it as a second parameter in my code, and it will find that specific element. So role is alert. Now, if I find that, you see that this is actually the text that we wanted. So again, as I said before, you can do .text to get the text, and you have the warning message here. Okay, so this is this like second parameter that you can put in the find function is very useful if you're looking for a specific thing on the website, right? If there is only one div tag, then it's easy, but in most cases you'll have several of them, and you'll need to be a bit more specific. Any questions so far on that before we go to our main challenge? I think there's a few questions here. Okay, I will try to put things a bit bigger. The name of this software, so I'm writing in Python, and we are using Jupyter Lab, or in this case, I'm using Jupyter Lab. You can use Jupyter Notebook, which is very similar. I can actually send you the package because you need to install it. Jupyter Lab Python install. So you can do everything I'm doing right now. You can write it on any website that you can write Python code inside. It doesn't have to be Jupyter Lab. It's what I'm most used to, and it's used a lot in data science. It's good for like exploratory stages of writing code, but you can do it on whenever you want. So if you do want to use Jupyter Lab, you have to have Python already installed in your computer, and you have to install this Jupyter Lab package. Okay, so I'm going to move on to our main challenge. So our main challenge is to scrape, as I said, all the titles and prices of all the books, right, and put that in a data frame. So the first step is to find blocks that have the information that I want, right? I'm for each book, I'm not actually trying to find just one piece of information. I have the title and the price, right? And what will make it easier is if, like, for example, if I click right now and I hover over now, if I find a tag that highlights the two things that I need, the title and the price, right? Instead of going directly to each one, we're going to kind of make a loop in Python that goes through all the books, and we're going to identify basically a single book through this tag here. So there's this article tag with the class product pod that has all the information for the first book. And if I actually, just to confirm, go and check the second book, you can see that it has the same article tag with the same class. Okay, so it's this. If I find all of the tags with this syntax, then I can kind of get all the books individually. But importantly, we were going to use a bit of another function, which is find all. So instead of just finding the first one, it's going to give you a list of all the tags. So let's try and do that. So if I do scraped and I do find all instead of find, and I wanted to find a article tag. Sorry, I don't know where I'm writing, article tag. And to be more specific, I want this class attribute product pod. So normally I would write this as class equals, with quotes, product pod. But because class is an important code in Python, you have a class object basically that you write a lot in Python. It's kind of reserved. You can't write it in Python like that, or it will think it's something else. So this is just a single example of you have to put this underscore after, since it's referring to the class in HTML and not the class of Python, right? So it's just a thing that you have to remember. If you're using Jupyter Lab, it's easier to remember because it's going to highlight this in green. Other softwares will do similar things. But it's a thing to keep in mind that when you're using the class attribute, you need the underscore afterwards. So if I run this, it's lots of HTML, but so basically it's a list. I'll do a little recap for those of you that aren't very used to Python. Um, in Python, you can make a list with square brackets, like that, and you put several things separated by commas in there. So this is a list with 4 numbers. I can print it. List, and here you go. It's basically just a way of storing a list of items. It's a good name, and it's separated by commas, and you identify them because of the square brackets. So deleting that. By looking at what was printed from this find all, I can see from the square brackets that I have a list here, and that's what we wanted, right? We wanted a list of books. Let me put back my list again. One important thing when working with lists is how do I get, for example, just the first item of my list. So in Python, selecting things is always writing the name of the variable. And then usually you're going to put square brackets after that. And since lists are defined by indexes, starting at 0, so this is the 0th element of my list, the first one, the second one, the third. I can just put the number on inside the square brackets. So bracket 0 gives me the first element, 1, the second, and so on. So I can do the same thing for here. But let's first save, since we already wrote a lot of code here, I can save this into a variable name, books, for example. And then I can access just the first book using the square brackets 0 notation. And here you can check, it's actually not that much HTML code now because it's just the single book. And if we look inside, here I have the title, and here I have the price. So as we tried to do, we found a structure of HTML that has all the information that we need inside it. So the last step that we need to do is actually just highlight and get specifically the title and price from this book. So first, let's just do it for one book, and at the end, I'm going to go through it on a loop and do it for all the books. Okay, so book 0. Again, since this, even though we started with this scraped variable that has a lot of HTML code, here, book 0 is still HTML code. So all the functions that we were running on this scraped variable, we can do the same thing on book 0, for example. So I'm going to copy this down here. So I'm going to find just one element, so I can do the dot find. I don't need to find all. And as you can see, it's the same syntax as before. Instead of having scraped here, I have books 0. And I want to find, let's say, the title. So the title is, so there's 2 ways you can find a specific tag. Either you do it like we've been doing so far by getting the specific tag. So it's an A tag. And then to be specific, since in this case you have 2 A tags, 2 links, you need to have an attribute. But here we run into a problem because the attributes that we have are href. It's a link to something that you probably wouldn't have before you start coding, and title, which is what we're trying to find, right? So none of these attributes are actually, it's not information that we have beforehand for every book. If we had it, we wouldn't be needing to web scrape. So another way to do it is just to go in order. So as I said, we have like this tree structure to HTML code. And instead of just looking for a specific thing in the code, we can just go generation by generation until we are in the right spot. And here again, it's easier to see it in the browser. Let's identify the title. So it's this tag here. put it a bit bigger. Let me put this a bit bigger as well, sorry. Okay, so this tag is here. I can see, I can go all the way up to my article tag, right? So here's where we started. Remember that we were to finding individual books by this tag. So I can see that the title that I want is inside this H3 tag, which is the first H3. So I can do find H3, and we're getting closer, right? And inside of this H3 tag, it only has, it's the first link. So I can do .find, okay. And now I have the correct tag. I can do .text and so on, right? Problem is, if I had just done .find a initially, they would have found the first link inside the book, which actually isn't the title. It's the image, probably. It's something to do with the image, right? So this is a different method of getting to it, and it's more useful if you're close already to the target content that you want. So in this case, we already had the single book. To get to the title, it was just 2 steps, so we can just do 2 finds. Now, a problem you can notice here is actually sometimes when the titles of the books are too big, it's not displaying the whole title, and we usually want the full title, right? Or it's kind of not, we were getting incomplete information. But luckily, or because it's useful for the programmers that made the website, you have this title attribute inside the tag that actually has the full title. Yeah. So instead of, in this case, is a unique situation which you actually don't want the content inside the tag. We want the content inside a specific attribute. So again, this code I have here is, let's call this title tag, just to save it so we don't have too much code in the same line. And now I can show you title tag again. So it has all the information we want, but instead of doing .text, get the content, again, I'm going to use square brackets to select a specific part of it. And what we wanted was the title attribute, right? So you can use this notation of square brackets, quotes, and the name of the attribute to get the information inside the attribute. Make sense? So if I wanted to get the href, for example, I would do this, and I get the file of HTML. But in our case, we want the title, and there you go. That's the full title. Since it's just one single step, I'm going to actually put it on this one line, call it title, and now I have saved the title. And finally, what we want is to get the price. Here, if I look again at let's look again at our single book. Books 0 is my first book. I see down here I have this tag that has the price. And in this case, I don't have to go step by step because I can see this attribute price color is probably unique to the price tag. So I can just find it through that. So I can do find. It's a p tag. And again, class with an underscore, specifically in this case, price color. And now I have the tag I wanted, and in this case, I do want the content inside, so I do .text. And this is still a string, like it's still showing as text, and maybe it will be useful for my data frame to have it be a number. So in Python, we have numbers like this. Let's say 12 is 12, and I can check the type like this. It's an integer. If I do point something, it becomes a float. And if I do the type of text, it's a string. At the moment, since it has the quotes, it's a string, and I might want to make it a float, right? Like if I do 51.77 without the quotes, it should be a float, right? And this is so Python understands that this is actually a number and not text. So to do that, I can call this price text equals price text here. So I need to remove the pound symbol and then convert the string into a float. So again, I can use that strip function that I told you about. It's useful. So usually if I do dot strip, normally it's just removing empty space on the beginning and end. But if you specify inside the strip a specific letter, symbol, or number or anything, like pound, it will look for a pound symbol at the beginning and end and remove it. So that's useful in this case. And again, to convert anything into float, you just put everything inside round brackets, type float before, and you see now it's no longer has the quotes, it means it's a float. Okay, so this is my price. So I can say that price equals, and I can check it, check if it's right. Okay, so I have 51.7. Okay, so the final step will be to loop through all the books, but I'll do a bit of a break for questions if anyone has any at the moment. Okay, you put the about the VS Code ID. Yes, if you use VS Code, you can run a notebook on VS Code, so that's useful. Any questions? Okay. So let's go to the final part. Now we're going to have to loop through all the books and get the title and price for each one of them, right? And we want to store that in a data frame. I'm not sharing my screen.
João, so sorry to interrupt. Can we answer another question? So
yes.
A question by Isabella. Instead of searching by class, can we search an element in a specific position? Say, I want to read the third element of a list only.
Okay, so that's a good question. So if as I said, there's the two ways of, let me share my screen again. There's the two ways of looking for it is either if you know the attribute of the specific thing, you can look through that, but in your case, you don't, or you can go in order through the structure using find. But if you're using find, it's always getting the first. And in your case, you're asking if you want to get the third one. So the only way to do that, you can't find the third one. You only have access to find or find all. But if you use find all, you get a list of multiple items, okay? Right, so let's pretend I'm gonna write a dummy list just for an example. Book one, book two, and book three, okay? And as I said, if you want to access a specific element of a list, you can use the square brackets and then a number in the syntax. If I want the third one, since Python starts at 0, it's actually the number 2. And if I do that, I will access the third thing in my list, okay? In our case, for example, we did the find all for the books, right? It has all the different books here. And if I want to get the third book, I'll do square brackets 2. And here it is, okay? So the third book is this 50-pound book. We can double check. Yeah, submission, 50 pound. So there you have it, okay? So you can't find the third one. There's no function to find the third book, but you can do the find all and then access the third one through that. So you really have to keep in mind when you're reading the HTML, is this the first time it's appearing? Is it not? Usually you really want to try and identify it through the class, but as you said, there might be a situation where you want the third book for some reason, and not all of them. You can just do the find all and use the square brackets to find the specific one. Okay.
And just one more thing. So from the previous question we had, Rob also asked, do you have a link that explains how to set that up regarding the VS Code?
Setting up the VS Code. If you have VS Code already installed and Python already installed, you can just open, if you have the file to a notebook, you can open it. In this case, I'd have to, maybe I don't know what Chiara has already prepared to send you at the end. I don't know if you have access to this notebook. One way you could do it, let me try actually. If I have Visual Studio Code open here, you can make a new file that ends in dot. So test dot. Sorry, this is really small. I'll change that in a bit. You should end it with I, P, Y, and B. That should be a notebook. And if I open it, so let me full screen this. Okay, so if you make a new file that ends in I, P, Y, and B, open it. It'll be a Jupyter notebook in your VS Code. I'm not sure if you have to have Jupyter Notebook installed from Python. Probably not. So I think it should work. But if not, you can do pip install notebook to get a notebook. So that would be one way to do it in VS Code. I tend to prefer doing it in Jupyter Lab or Jupyter Notebook in the notebook in the browser. But yeah, it's different options if you want it. Okay. Is that it for questions? Yeah, looks like it. As I said, the final part of that we want to do is loop through all the books and get all the titles. Okay, so this is actually a good dummy list that I can show you how a loop works. So in Python, you can do a for loop. So for example, book, here you write any word you want. For now, it can be I, it can be whatever you want. I'm going to do book because I know in advance that I'm looping through books. And if I do my list, just for an example, I end it with a colon. So this is the kind of the syntax for doing any for loop in Python. For something that whatever name you want in, and then a list. And for now, I can, for example, just print the book. So what it's going to do, what Python is going to do is going to go individually through each element of your list and run code. So I can do print book. I can print book plus hi, and it's doing that. So it's going to run this code that's inside the for loop for each book. So in the first iteration, book is book one. The second iteration, book is book two. Third iteration, book is book three. Great, and you can have lots of code here. Doesn't matter, right? In our case, we don't want to use this dummy list. Our list of books is actually called books. If I print book now, it's going to be a lot of HTML code, right? But since up here we already managed to get the title and price for a single book, basically we can do the same thing inside the loop for a single book, right? Because this book variable is going to be an individual book each iteration of our loop. Okay, so I can basically copy paste the book here. This was my first book. I can copy all the code after it. So title equals book, and then dot find h3, find a title, right? So instead of having book 0, which was the first book, we have book singular, which is each of the books in the iteration. And I can, for now, just to check everything is going well, I can print the title, and it should get all the titles in the page. Okay, so already now, this hasn't been a lot of code so far. You got all the titles from a single web page. If you were to copy paste, you could write this code if you're practiced in like 2 minutes. Copy pasting would have taken just to do this probably longer than that. But as you get more complicated, the benefits are even bigger. So let's try and get the price as well. Here is the code, at least to get the price text. So price text equals book, and then paste. I got the text from the price. And again, finally, to get the price, it's just exactly this. And to check, I can print the price. And here we go. We have all the prices. And if I print the title again, you get everything. Okay. So instead of just printing, we might want to actually save this information. So I'm actually going to make a dictionary. So I can say book. No, so my dict equals a dictionary. So in Python, you have dictionaries. I can go a bit over that quickly. A dictionary is kind of like a list, but you have pairs of elements. Instead of just having a list of singular things, you have pairs of keys and values. So I can say first, or let's say an example, a more realistic example. I can say name of someone. Let's put in my name is João, then a comma, age is a number. So let's pretend I'm 100 years old, and so on. Height equals 200 centimeters, on and on. Right, so it works in pairs, not equals, sorry. It works in pairs of elements, a key and a value, a key and a value, a key and a value. So I'm doing a lot of syntax errors, but so here I have 3 keys, name, age, and height, and 3 values. João, 100, 200. And they don't even have to be all strings. They can be numbers, strings, everything. Okay, so since here we want to store 2 different things, title and price, I'm going to use the same syntax. I'll say title is, instead of actually writing down the title, I can put the variable title that we made, right? So this title at the first iteration is A Light in the Attic. So I'm saving title as that. And price is a number, but again, we already have the number instead of writing it. Sorry, syntax is wrong. So the keys have to go in strings, but you can put variables as well. So basically, if I now print this dictionary, I have for each book and 1 dictionary that has a title and a price. Okay, so that's the syntax to do that. And since I want to store all of this together, I can actually, before my for loop, make an empty list. So books, I'm going to call it df or data frame, since that's we're going to make a data frame at the end. It's going to be an empty list, so nothing inside it. And instead of, so I can write a list with the elements inside it already, or I can make it empty and use a function called .append, which will add an element to my list. So I want to append my dict. And just so you can see what it is doing. Here you go. Right, so it's what I had before basically, but I put it all in one big list that starts here, ends here. And to wrap up, having all of the information saved in one variable, books df, I can actually, so this is a bit out of the scope of the web scraping, but if you downloaded and the package pandas, you can import it in this way. And you can do pd.dataframe. So this is a package we use a lot in data science to work with data frames, like lots of big sets of data. And I can do pd.dataframe books. Yeah, it's basically going to show that in a bit more visual way. So that's why I wanted to do it. Here we go. We have one table with title and price, with all of the information we want. And I can actually make this look a bit better by putting better titles here. So I'm going to put this in capital, price, dollar and pounds. Here we go. And a nice thing we can also do if you have pandas is if you have a data frame and use a function to CSV, books.csv, I get a CSV file here with, so now I actually have it saved in my computer, all the titles and prices of the books. Okay. So just to recap, this function to CSV and then the file name that I want to give it. So it's basically just saving, as if you did file save on Excel. And so that I have everything in my computer saved now. So I think that's more or less it for me, but I'll take a bit of time now to answer a few questions if anyone has it. I can also, if anyone wants me to go over any of the things I've done so far a bit more slower or anything like that, I can also do that. So leave a question for that.
Okay, so we do have one question. It's more like a request. Hi, can we get a copy of the Jupyter notebook?
Okay, so I can do that while I wait for more questions. Yes, the link that we're going to send to you doesn't have the Jupyter notebook in it, but it will have all the slides, and it actually has some more challenges that you can do after this if you want to go on with this exercise that I was doing. But I can start saving this file and sending it, or I'll send it later. Actually, yeah, that'll be easier.
Yeah, I have shared in the chat box already the Le Wagon Learn platform. So okay. You have to use this token, don't forget, in order to access the information. Okay.
Am I able to upload the file here? No, right? It has to be a link. Or can I? No. Yeah, so I can send it to you. Maybe I can do a Google Drive link or something like that.
Yeah, for sure.
Yeah, I can do that.
And also, just to add another information, we are planning to do another workshop on data science in a month or so with the more advanced level of Python. Is that it, João?
Yes. So we are planning to do another workshop for more of like an introduction to machine learning, which is more of what we focus on in our bootcamp. It's a bit more complex, at least compared to the basics that I gave you for scraping today. Obviously, scraping can get very complex as well, but yeah, it's really fun, and it's a really good introduction to what data scientists do on a day-to-day, really, like in their jobs. It's used all over the world, and more and more each day.
So we'll keep you posted, all of you, so you can join us again, and we can learn a little bit more. I can also share with you that Landing.Jobs and Le Wagon, we joined forces, and we are offering now 50 scholarships for part-time learners, 2 courses, so web development and data science. I will leave now as well a link to the page in case you want to know more. And just to let you know, the deadline is May 31st. Okay, so just 1 second, I'll put the link here. It's a good opportunity to take one of these courses. Okay, perfect. Let's see, I think we have another question here. Yes, a question from Thomas Melo. How can we avoid getting blacklisted whilst trying to web scrape multiple pages of the same website? Is there a go-to way to make sure we won't get blacklisted from the website, besides waiting for longer between each request?
Okay, so yeah, you already answered what the first option is, right? So a lot of pages have limits to how many requests you do every minute or every 10 minutes or something like that. The easiest way to go around that, and that's probably what I would recommend, unless if you're building like a professional application already. If it's just for to get it a one-time use or for your own use, I would recommend doing that. Just adding a delay. So I know I can only do 100 requests a minute. I'll be doing a loop with I estimate like 10,000 requests, but I can put like a piece of code there that says every 100 wait 10 minutes or 1 minute or whatever it is. It doesn't it depends on the website. So that's one way to do it. If you really wanted to do more, you'd need to set up proxies. You'd have to search a bit into that, but you'd have to set up different proxies so that you're kind of fooling the server into thinking that it's different computers accessing the information. So you'd do like 10 different proxies and have them all running at the same time, but that's more advanced than what you need to if it's just for a single time use or for your own use, unless it's like a website that you want to have running that's automatically scraping things. It's not really necessary for that reason.
Perfect.
More questions?
Well, we have one more regarding the scholarships. On the above courses, would it mean we can attend in person or online? I'm not sure about this one. João, do you know the answer? No.
Not
Chiara,
don't know the answer
may.
yet.
Yeah,
But
Chiara may know.
I'm assuming if it's soon, it's probably would be online. But for sure, we were planning on doing in person.
Andre, you can go to the website and you can fill the form, and someone will get in touch with you. Okay, so I believe so, but I don't know. I don't want to make a mistake here, so it's better for you to check it. Okay,
for sure. I just put the link for Google Drive. Can someone check in the meantime if it's working? Okay.
And we have here another question from Anna. Our script might fail because the front end of the website we are scraping changed. Any suggestion on how can we keep track of it, and other than fail fix loop?
Okay, so if other than fail fix loop, which is the more likely scenario, the one way you can fix it is if you have some example of what you're scraping that you know already predefined. So let's say I'm scraping the books and I know the first book is always going to be the same, or I already know the title of the first one, something like that. I can kind of work backwards to what we did today, right? I can look for the text, the specific text I already know in the code, see what tag it belongs to, see like, and from then on you can like kind of interpret the structure of the code if you don't know the tags, right? So you kind of need at least one of the ways. Either you already know the tags because it's fixed on the website and then you can get the content, or you at least need to know one of the pieces of content that you know for sure is in there, and you can work back to find the structure, and then you can extrapolate it to the other. Like you only need one content, and then you can find all the rest of them once you figure out the structure from there.
Okay, great.
Does that make sense?
So another question from Isabella: how would the Selenium package be used for web scraping in this example? It was mentioned but not used.
So yeah, I'm not going to go over it today because it would take quite a while. So the way the Selenium package works is it's actually, since it's meant to work with JavaScript websites, it's actually loading it's going to use your browser. So if you set up Selenium, it's kind of an optional parameter you put in there, but you can set up Selenium and you can see on your computer, it pops up Google Chrome, it clicks stuff, it waits, right? Because there's JavaScript running on it and stuff like that. So instead of the beauty of Beautiful Soup is you don't actually have to open the browser, you don't have to click on stuff. It's just part of the HTML code and you're using that. What Selenium does is actually kind of emulate what a user would do on the website. So it opens the tab, goes to the link that you want, you click buttons, etc., and you wait for that. But that does take a bit longer to set up, so I don't think I have time for that today. But for sure, and I would definitely never recommend using Selenium for what we did today or similar websites that are static, because it's much more of a hassle to set up, and there's no advantage to it. So the only advantage is there are some websites that you can't scrape with Beautiful Soup. And a good way to see, to double check if it will work with Beautiful Soup or not is trying to open the HTML content of a page and searching for, like, do Control F or Command F to search for the specific content that you want, and check if it is in the HTML code or not, right? Because if it's using JavaScript and generating things live, it probably won't be there, or at least not when you load the page initially, right? So that's one way to check. If it is on the HTML the source already, the content that you want, then there's no reason to use Selenium.
And also, Sunil is asking, which one is the best, Scrappy, Beautiful Soup, or Selenium?
Okay, so it's, as always, it depends on what you want to use it. Beautiful Soup is the best in terms of ease of use. It's definitely the easiest to set up and write code for. So if you can use Beautiful Soup, most often you will want to do that. Selenium is, as we said, the advantage is to do with pages that have a lot of JavaScript that you can't do with Beautiful Soup. And Scrappy, the main advantage is that it's the most efficient and most performant. So if you are actually building like a official product, or like a real, like it really matters how fast you're scraping and everything, then I would recommend using Scrappy. But it's also more difficult to set up than Beautiful Soup. So if it's for your own use or for a one-time use, you don't really need Scrappy. But if you have a product, a live product that's constantly scraping, then Scrappy is the best option for that.
Amazing. So let's wrap up. Just to answer to Albina, yes, you can get the recording of this workshop just after we finish. The recording will be available in 1 minute, more or less. You can use the same link that we are using here now, and you can revisit all the information that João shared here with us. João, I don't know if you want to add anything else.
Well, yeah, I hope you enjoyed this taster for web scraping. Obviously, there's lots you can do for using it. Data science is obviously my field, and that's what I use it a lot for. But for sure, it's like a world of possibilities. And as from answering the questions I was doing here at the end, not only is it a tool that you can use for lots, it's also something you can specialize in and start doing, really like become a hacker and scrape LinkedIn and all of this. It starts becoming a very complex field in itself, just by its own. So hope you enjoyed a bit of a starter on that.
Just out of curiosity, so you decided to move from your to take this course at Le Wagon, and so this was the right choice for you. It is, we can see that you really enjoy what you're doing. So
for sure. Yeah. I think it's just like more and more. It already is kind of the field of the future, right? All the big companies are using data science. More and more countries. It started mostly just in the US, but now it's spreading to the whole world, and it's like kind of the future. And also it's great in my case, I love working from home. So if you want to be like a digital nomad or something, or a freelancer, it's a great field as well for that. Yeah. So I definitely recommend.
Okay, so finally, to our audience, if you're looking for a new challenge, there's a list here in the bottom of jobs with must or nice to have Python. If you want to know more as well, check the CTA green button. And closing this session. So this was really interesting. I hope you all made the most of it. And a big thank you to our teacher, João. Thank you so much for being here, sharing your knowledge, your experience with us. And I hope to see you all again soon enough. You, João, to another workshop, and
Yes, hopefully, yes.
all the attendees that were here with us too. Thank you so much.
See you.
See you.